Okay, so today we're going to look at the acceleration due to gravity experiment. And what I have here is a little spark generator, and up here is a pair of electrodes. We'll zoom in on them in a minute. There's a pair of electrodes in there, and the spark generator will generate a spark between the electrodes. Let me see if I can sort of show you that. Okay. All right. Now, that spark is happening 60 times a second. So that's 60 hertz or 60 cycles per second. So there's a spark every 1/60th of a second. So what we're going to do is we're going to take a piece of paper that is coated, and as this piece of paper falls through the spark gap, it will make some little marks. It will actually burn some little marks on the paper. So by attaching a weight to the paper and letting it drop while it's sparking, then you're going to get a mark on here every 60th of a second. And we know from what we talked about as far as free fall, we know that this object is falling under the influence of gravity. That's a constant acceleration. It's getting faster and faster and faster. So we would expect that these marks get farther and farther and farther apart. Okay? So let me show you how I'm going to do that. And I'll ask Dr. Variano to come over here and help me with this. Okay, so I'm going to put this piece of tape through the little spark gap. And it's sometimes, I got it. That's what happens. And sometimes it's a little bit tricky to get through there. Okay. So I'll attach the mass to the end of the tape. Now, when we drop this through here, when I hear the sparks start to happen, I'm going to let go, and Dr. Variano is going to stay down on the button until it hits the floor. That way we get dots all the way up the tape. Okay, I'm ready. Perfect. All right. So let's see what we came up with. Okay, so the tape that I just dropped through the spark gap, I've got it laid down here, and you can see that there are a number of dots, and these dots are spaced out equally in time. The distance between the dots gets larger and larger and larger because as the object falls, it's going faster and faster and faster. So for the data that you're going to analyze, I'm going to go ahead and mark some of the dots, and I'm not going to choose this first big blob. That's sort of like my reaction time when I was dropping the tape, okay? So I won't choose that one. I'm going to choose this next dot here. Then I'm going to choose, I'll number that 1. Then I'm going to choose every other dot. So delta t will be 1/30th of a second. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay? So you're going to need 11 dots for your data set. And you can see that this is not quite a straight line. That came from the paper wiggling as it fell through the spark gap. So when you talk about uncertainties in this experimental setup, you can talk about that one aspect of uncertainty. Okay? Okay, so now I've placed a meter stick near the dots. I placed dot 1 at 10 centimeters. So for every one, dot 1 will be at 10 centimeters. Then I'll give you data for the positions of the other dots to do the rest of the calculations. However, every single dot has a delta t, so the time between each dot is 1/30th of a second.